Hello. In this lesson, we're going to go over the basics of graphing. So hopefully a lot of this is review for you, but even if it's not, you should be able to quickly pick up on it, or I can help you if you have more questions. We're going to go over the Cartesian plane and linear equations, and also some X and Y intercepts in there. So like I said, if you have questions afterwards, be sure to ask me. But for right now, we're going to start with the Cartesian plane. So when we have an XY axis like this, remember the X is right here and the Y axis is right here. Positive values for X go left to right like this. And then to the left of the Y axis, we have negative values for X. Above the X axis, we have positive values for Y, and below we have negative values for Y. So that all should be no new news. And sometimes I'm going to ask you questions that can seem a little tricky if you're not used to them. So let me ask you this first one right here. And it says, if X is greater than 0 and Y is less than 0, then which quadrant are we in? So take a look at this first part right here. It says X is greater than 0. Now, that's a fancy way of saying what? X must be positive. So X is positive in these two quadrants right here, these two. So remember, we call this quadrant 1. We start in the top right, we call that quadrant 1. Then we go counterclockwise. This is quadrant 2, quadrant 3, and then quadrant 4. So I know that this restriction right here, it's a fancy way of saying X is positive, is automatically saying I'm in quadrant 1 or quadrant 4. Then it says Y is less than 0. Well, that's a fancy way of saying Y is negative. Y is negative in quadrant 4 and 3. So where are these two overlapping? They're overlapping in quadrant 4. So our answer here is quadrant 4. And yes, please use Roman numerals. It's just convention. All math books use it. You'll use it in the future. So get used to using the Roman numerals when you're talking about quadrants. It's the only time I think we actually use Roman numerals in math. Let's look at this one right here. If negative X is less than 0 and Y is greater than 0, then which quadrant are we in? So pause the video and see if you can come up with the right quadrant. All right, I'm assuming you paused it. You're being honest, right? This part right here, to make it a little bit easier, I just solve for X. So if you divide both sides by -1, remember when we multiply or divide both sides by negative and you're dealing with an inequality, you've got to flip the sign. So negative X divided by -1 is just positive X, and divide this side by -1, you still get 0, but this makes us flip the sign. So it's saying X is greater than 0 again, which means X is positive. Then it also says Y is positive. Remember, Y is bigger than 0 means Y is positive. So when is X positive? Once again, it's in quadrant 1 and 4. When is Y positive? 1 and 2. In this case, they overlap in quadrant 1. So this must be quadrant 1 right here. All right, let's look at the next one here. This one says X times Y is less than 0. Okay? X times Y is less than 0 is a fancy way of saying that when you multiply X and Y, you get a negative number. So how can this be? Well, if X is positive, let's suppose X is positive and Y is positive. When I multiply those two, I'm going to get a positive number, not a negative number. So that tells me that both X and Y can't be positive. When is X and Y both positive? Well, quadrant 1 is. So quadrant 1's out here. What if we say X is positive and Y is negative? Notice multiplying those two, it does give me a negative number because a positive times a negative is a negative. So this one works. What if X were negative and Y were positive? That would work as well. And if they're both negative, well, a negative times a negative is a positive. So that doesn't work. So these two cases don't work. It's these two right here that I need to find out what quadrant are we in when X is positive and Y is negative. Well, X is positive over here and Y is negative down here. So quadrant 4 is one of them. And then we had this other case right here when X could be negative and Y is positive. X is negative over here, Y is positive up here. Our answer are two different quadrants it could be in. It could be in quadrant 2 and quadrant 4. So we just write down as our answer quadrant 2 and quadrant 4. So sometimes these can be a little tricky, but I've tried to show you the trickiest ones so you can kind of get used to how to approach those problems. Because I know that every year I get students that struggle with them, and then they get them right once they start getting used to just how to approach them, and then they become easy problems. So a little bit of thinking required there. All right, the next thing I'm going to do is just kind of go over some things that you've had in your past, mainly like slope, y-intercept, the y equals mx plus b stuff. So let's take a look at that. Going back to slope. Remember, we describe slope as our rise over our run. You can think of it as a rate of change. Our formula for it, a lot of times we use y2 minus y1 over x2 minus x1, and we'll let the variable m stand for slope. Why? I don't know. Maybe it's because it looks like mountain slopes or something. So our slope is our rise over run. There's our equation for it. And then we have another thing we call the y-intercept. And this is, let's see, y-intercept is where the graph goes through the y-axis. The y-axis. So, for instance, suppose we have a slope that is at 0.5. Sorry, not a slope, a y-intercept. That's at 0.5, and then a slope of -2. Let's try graphing, and this is a line we're talking about. Let's graph a line like that. So the y-intercept is at 0.5. Remember, our x value here is first, and then we have our y value. So at 0.5, 1, 2, 3, 4, 5, we put a dot. And the slope is -2. Now, our slope, we usually describe it as a fraction because it's our change in y's over our change in x's. So I need to make it a fraction if it's not already a fraction. So I put a 1 under it. So this tells me to fall 2 and run 1. So right here, I've got 1 point on the graph. If you have a point and a slope, then you can graph the equation of a line. So here's our first point. Our slope is fall 2, run 1, fall 2, run 1. Alternatively, you could rise 2 and run 1 to the left, and you'd still create a line there. I'm going to take my handy ruler here and then draw a line through them. And there's the graph of that line with a y-intercept of 5 and a slope of -2. All right, hopefully you're still with me here. Let's now look at what we call the y-intercept form of an equation. So y-intercept. Equation of a line, that is. So we have a couple different ways we can write out the equation of a line. Y-intercept is probably the one that I have students come to me and they know it the best because it's gone over and over again in Algebra 1 and Algebra 2. So let's review y-intercept, and then I'm going to show you one that you've seen before but not used as much that's going to be even more helpful when you get into calculus. So y-intercept is that famous y equals mx plus b. And what's nice about this, remember I said if you've got a point and a slope, you can graph any line. Well, here we have our y-intercept. That's our point we're talking about. We know where that is. It's got to be on the y-axis because it is the y-intercept. And then we're going to have the slope of the line. So in our previous example that we used right here, we had the y-intercept. So that b value was +5. And we knew the slope was -2. So we could have written out the equation like that. So I give you the information spelled out for you, or I can put it in an equation and you should be able to pull it out and still graph it, all right? So that's the slope-intercept form of an equation. You got the slope, you've got the intercept. Remember, as we're talking about slopes, we can have, let's see here, let's write this out as types of slopes. You can have positive slopes, you can have negative slopes, you can have a slope of 0, and then you can have an undefined slope. So as we look at these graphically, if your slope is positive, it should be going uphill left or right. That's the way your line should be looking. If it's negative, it should be going downhill left to right. If it's 0, it should be like a flat line there, horizontal, parallel to the x-axis. And if it's undefined, it should be going straight up and down. So these should make sense. Typically, notice if we're talking about the rise over run on a flat line like this, we're rising up and down none, and we're running however much we want. So 0 divided by anything is going to give me 0. So your slope is 0. If it's undefined, then we're going up and down whatever we want. Let's say it's 5 again, but we're going left or right. Our x value is changing none at all. Well, you can't divide by 0. So that's why it's undefined there. Okay. So those are the 4 different types of slopes that you can have. Let's try a little bit of practice on these. Let's start with an equation. We'll put it in y-intercept form. Let's suppose we have the graph of y equals 4x minus 2. Pause the video and give that a try graphing that out. All right, so first thing we're going to do is identify our y-intercept. It's going to be negative this time, so it's -2. I'm going to put my point there. That's our first step. Get the point, 1 point graphed, and then use the slope to find additional points. The slope here is +4. If we make that a fraction, it becomes 4 over 1. It's positive, so it's going to be going uphill left or right. So we rise 4, we run 1. Rise 4, run 1. And once you got about 3 points, plot it. You can easily trace a line through those, and you've got your graph. All right, let's try another one. Let's look at 6x plus 3y equals 12. 6x plus 3y equals 12. Now, in this case, the y is not solved for, so we cannot say that this is in slope-intercept form. So we need to solve for the y. So let's see, let's move the 6x over. You get 3y equals -6x plus 12. I just subtracted 6x from both sides. And then divide both sides by 3. So you get y equals -2x plus 4. And now it's in y-intercept form, and I can plot that 4. That's my y-intercept, 1, 2, 3, 4. And -2 over 1 is my slope. And so now we have my line here. All right, so that is slope-intercept form. We have another form that's used quite a bit, and that is called point-slope form. So point-slope form, if you remember, looks like this. Y minus y1 equals m times x minus x1. And this becomes pretty useful in calculus. In fact, I kind of wish that algebra teachers would focus on this as much as they do slope-intercept form. But I understand when you're learning all these things, it's hard to take it all in at once. So this actually is as simple as slope-intercept, except for in slope-intercept, you have to have the y-intercept. That's the point you're graphing. In this case, your x1, y1 term can be any point that's on the line. It doesn't have to be the y-intercept. So if you're given something like this, say you're given -2, 0, and 3, 1, and I ask you to write that equation in slope-intercept form, well, we need to know 1 point that's on the line. Well, I gave you 2, so you just pick one of them. And we need to know the slope. So I don't know the slope just yet. That's when I'm going to use that slope formula, you know, the y2 minus y1 over x2 minus x1. And I suggest for all my students to do this. Label your points. So this is x1, y1, x2, y2. And then write out this equation with the minuses signs first, because sometimes we forget to subtract there, especially if we're dealing with a negative number. So x2 is 3 and x1 is -2. y1 is 0 and y2 is +1. Let me make sure I put that in here right. y2, no, I knew I was doing something. 1 should go right there because it's y2 minus y1, 0. Even I make mistakes, so make sure you're double checking your work and labeling things properly. So this gives me 1 minus 0, which is 1, 3 minus a negative 2, which becomes positive 5. 1/5 is my slope here. Now, look at how easy this is. Once I've got that taken care of, I'm going to write in y minus something equals the slope 1/5 times x minus something. And what goes in right here is that 1 point that's on the graph that we know of. So you can pick either one. I'm going to pick the 3 and the 1 here. So the 3 and the 1 go in right there. This is my answer in point slope form. Equally correct would have been y minus something equals 1/5 times x minus something. And instead of picking this point 3, 1, I'm going to pick the point negative 2, 0. So negative 2 goes right here, and 0 goes right there. Cleaning it up, I get y minus 0 equals 1/5 times x plus 2. This becomes plus a positive. And so that's equally correct right there. So it doesn't matter what point you pick, so long as you pick, point that's on the line. Please, because there's an infinite amount of answers here you could have because there's a lot of points on a line, right? Please stick with the 2 points that I'm giving you here. It makes it a lot easier when I'm grading things and I don't accidentally mark it incorrect on you. The other thing I want to note on both of these forms is we always have this x and y that are not filled out. Those x and y stand for any point that's on the line. So if I gave you another point, let's say 3, 4, I could say, is that point 3, 4? Is that on this line right here? And all you got to do is substitute in 3 for x and 4 for y, and you should get a true statement if it is. Let's see if it is. 4 minus 1 is 3. And then putting the 3 in right here, I get 3 minus 3 is 0, and 1/5 of 0 is 0. Do I get a true statement? I don't. 3 does not equal 0. So you can say 3, 4 is not on the line. This doesn't just work for lines, it works for circles, ellipses, parabolas. Those x's and y's, there's always going to be those 2 variables in the equation, and you can see if a point lies on the graph just by plugging in a point and seeing if you get a true statement or not. So we'll see that come up a lot, all right? You try one. So that's point slope form written out for you. Let's see if you can do another one. Let's try -1, 2, and 2, 2. Write the equation in point slope form of that line there. All right, I take it you pause the video and try to write it out. Let's start with just finding the slope. So the slope, we have a minus and a minus here. I'm going to label this x1, y1, x2, y2. And I'm going to substitute it in. So my y's go up top. I've got a 2 minus 2 over 2 minus a -1. And this becomes 0 over 3, which is just 0. So my slope in this case is 0. It should be a flat line. So let's put it into the equation. We've got y minus something is equal to the slope. In this case, it's 0 times x minus something. Pick a point and plug it in. And there's your equation in point slope form. You could have also picked the other point and gotten x. Let's see here. The other one would have been -1, 2, right? So we could have said y minus 2 here is equal to 0 times x plus 1. That would have been equally correct as well. Okay? Let's try another one. Let's actually graph one. So let's suppose I give you this, that the line goes through the point 4, -6, and it has a slope of -1/2. So I want you to write the equation of that line in point slope form, and then I want you to graph that line. So this time I actually made it a little bit easier on you. I said I gave you the slope, so we don't have to calculate the slope there. And you've got this point right here. Now, here is a case where doing it this way is a lot easier than using slope intercept, because slope intercept, you got to say, What's the intercept of the equation? What's the y-intercept? So you have to put 0 in for x, try to figure that out. Here, we can just start off with this point right here. Put that in the equation with our slope and graph it from there. So that makes life a little bit easier for us. So we're going to say y minus something is equal to the slope, which we know is -1/2 times x minus something. And I can never write inside these lines, so sorry if that bothers you. I know that's probably going to bother some of you out there. That's why I usually use blank paper when I'm doing math, but it is what it is right now. So we got -6 we're going to put in. We've got 4 that's going to go with the x right here. This becomes a +6. So when we clean it up, we get y plus 6 equals -1/2 times x minus 4. That's the equation of our line. Let me grab our graph paper and we will graph this thing. So remember what I said, when you're making a graph, you need a point and you need the slope and you can graph the line. So we know that the point is at 4, -6. So 1, 2, 3, 4, 2, 4, 6. And the slope is -1/2. So I can fall 1, run 2, or I can rise 1, run 2 this way. And remember, since it's a negative slope, it should be going downhill left to right, which it is, so that's a good thing. My camera turned off on me. Let me turn that back on. I'm so boring, the camera fell asleep, right? No, it has a timer on it. It clicks off if I talk too long. So there's the equation of our line there. And that's it. So let's try one more before we move on, just in case you need to see another example. Let's try it with the point 2, 4 and 4, -4. So write the equation of that line and sketch the graph. So when we look at this, this is one of those where we've got to find out the slope. So we say slope is equal to y minus y over x minus x. So I always just kind of pick this point on the right and say this minus this, and that keeps me from switching them around. So -4 minus 4, and then 4 minus 2. 4 minus 2 is 2. -4 minus -4 is -8. And our slope is going to be -4. Let's put that in the equation. So we need y minus something is equal to the slope times x minus something. I'm going to pick this point right here, 2, 4. Putting that in, there's my equation. Equally correct, you could have said y plus 4, when you put that -4 in, equals -4 times x minus 4. Okay? So there's the equation. Now we need to graph it. So to graph it, let me plot that point 2, 4. And the slope is -4, so I'm going to go down 4. That's 3, 4 over 1. Down 4 over 1. It should go through the other point 4, -4, and we see that it does right there. It's just a nice kind of double check. And I'm going to line it up and graph my line. Please use a ruler if you're graphing these things for me. It makes it look so much crisper and nicer than you trying to draw a line. You know, trying to draw a line like that does not look as nice. I don't care how good you are. You can't draw a straight line better than drawing it with a ruler, okay? So please use a ruler, make them look nice, crisp, and neat, so that way I can follow your work and I can brag about how good you are at drawing lines with a ruler. All right. So that pretty much wraps it up for linear stuff. Linear meaning it's a line that we're graphing. But sometimes we want to graph other things like quadratics or parabolas. So let's suppose we had something like y equals x squared minus 2. Now, I'm going to take you through what I call the baby method of graphing it, where we just make an XY chart, plot some stuff. But eventually we're going to move away from that baby method and we're going to get into using transformations and knowing our parent functions and those sorts of things. And maybe you already know it. That's great. but I'm trying to get us all on the same page. So if you're not there yet, we're going to get you there. So with this, go ahead and make a chart that goes like this, X and Y. And for our X values, we're going to use -3, -2, -1, 0, 1, 2, 3. And so when X is -3, we're going to square it. We get +9, and 9 minus 2 is 7. Go through and fill out the rest of the chart. So you can pause the video and do that. I'm just going to write it out right here. All right. So check your answers there. Make sure that they line up with mine. And so now what we can do while we're still using this method here is go through and sketch out by just plotting these points. So we have -3, 7, 1, 2, 3, up 7, 3, 6, 7, -2, 2, -1, -1, 0, -2. And we're going to see a line of symmetry here because we are graphing a parabola. And now we can sketch this curve. Now, like I said, this is the baby method of doing it. It takes a lot longer. It's easy to make mistakes. We're going to start going through and really analyzing these things and making sure we know all the parts of a parabola. But we're just getting started here. So my question is, on the last thing we talked about with lines, let's look at some of those lines we graphed a second ago. We talked about y-intercepts. We can also have x-intercepts. So I can ask you, when does it cross the x-axis? So that's what I want you to be able to come up with here on this parabola. What is the x and y-intercepts of this parabola? So here is the key point when we're talking about x and y-intercepts and how to find them. When I'm on the y-axis, we call this a y-intercept, right? What is the x value when I cross the y-axis? All right. Well, the x value must be 0 because you're on the y-axis. It doesn't matter if this graph we're crossing right here, here, or here. Anywhere on this line, the y-axis, the x's value is 0. So if I didn't have the graph already done, if you're just looking at this equation right here, y equals x squared minus 2, I know that the y-intercept occurs when x equals 0. So put 0 in for x, 0 squared minus 2, and you will get your y-intercept. 0 squared is 0, minus 2 gives you -2. So 0, -2 is the y-intercept. Now, this one has 2 x-intercepts. So think about it. The x-intercept is where it crosses the x-axis. What must the y value be there? Well, anywhere along the x-axis, y's value is what? It's 0. So this looks like it's crossing in a spot that we call non-integral. It's not crossing at a pretty spot. It's somewhere like 1.2 or 1.3 something, and then -1.1 or -1.3 or something like that. You can't tell just by looking at the graph. So to get the most accurate information here, we need to go back to the equation and put 0 in for y. So if I do that, I get 0 equals x squared minus 2. Add 2 to both sides. Square root both sides. Now, I introduce the square root here. And when I'm introducing the square root, that means that you could have a positive root and you could have a negative root there. So remember, when we're looking at this, we're saying, for instance, the square root of 9 equals 3, right? Well, the square root of, well, let's ask, why does it equal 3? It's because 3 times 3 equals 9. Square rooting is the inverse to squaring. But we could have also said -3 times -3 equals 9 as well, right? So the square root of 9 could be 3, could also be -3. Now, typically, if I leave it like this, if I'm asking you the question and I say, what's the square root of 9? Well, because I didn't put a negative in front of it, you're assuming I mean what we call the principal root or the positive root. If I put a negative in front of it, it means I want the negative root. If I put a plus and a minus there, it means I want both roots. In this equation right here, though, the author of the equation did not tell you if they wanted the positive or negative root. You're the one introducing the radical. So you have to assume the positive and the negative there. So we get our answer to be plus or minus root 2. And so now the question is, what is positive root 2, or what is the root of 2? And I want to make sure that we know how to work Desmos. So I'm going to switch over to Desmos real fast. You click on the graphing calculator, and it does a lot of things here. I'm not going to go through it all right now, but real quickly, if you want to know the square root of something and you can't find the calculator for the course, I mean, for a test or quiz, you should have the calculator for the course in there. But if you put in the square root of 2 right here, it tells you it's 1.41. Going back to our other picture over here that when we graphed it, let's see. Remember we said it was around 1 point something that way and negative 1 point something that way. Now we know it's negative 1.4 and positive 1.4. So that's how we find our x and y intercepts. You put 0 in for x to find when does it cross the y-axis. You put 0 in for y to see where it crosses the x-axis. It won't always cross the x-axis, all right? It may not cross the y-axis. So sometimes you'll get those and it'll just show you like something that's not true, or you'll take the square root of a negative number, and that's how you know, like, hey, this thing isn't crossing the x or the y-axis. Let's take a look at a few examples. So first one is going to be y equals 3x plus 6. So on this, I want you to find the x and the y intercepts. So let's see, for the x-intercept, we need to put 0 in for y, right? So we're going to put 0 in for y. We get 3x plus 6. Subtract 6 from both sides. You get 3x equals negative 6, or x is equal to negative 2. So our x-intercept occurs at negative 2, 0. For the y-intercept, we're going to put 0 in for x, so we get 3 times 0 plus 6, or y equals 6. And this kind of shows why the slope-intercept form works the way it does. Remember how we would say that b value out there in y equals mx plus b equals the y-intercept? It's because when you put 0 in for x here, it just makes that go away, and you see what your y-intercept is. So when x equals 0, y equals 6. We can switch over to Desmos and try this out. So if you have y equals 3x plus 6, you can see right here that it's crossing at negative 2, 0 and at 0, 6. So you got your x and your y-intercept there. Let's try another one. Let's try y equals x cubed minus 4x. So y equals x cubed minus 4x. So as we do each of these, I want you to pause the video and see if you can figure it out before you see me do it. Because it does no good if I just sit here and do it all and you copy it, whatever. Now that you kind of got an idea of what I want from you, pause the video, try out each example, and then hit play and see if you got the answer correct. So the x-intercept once again happens when your y value is 0. That's when it's crossing the x-axis. So we put 0 in for y. And now we got to solve this thing for x. So be careful here. Don't add 4 to both sides and then divide by. This is what you don't want to do. Don't say 4x equals x cubed, so 4 equals x squared. That's not what you want to do. You'll get part of the intercepts, but you won't get them all. And the problem is if x equals 0, if that's an intercept and you divide both sides by x, you're dividing by 0. And that throws off the whole thing. So that's not how I want you to solve it. Instead, factor this thing. So factor it out and you get an x in common. So you end up with x squared minus 4 times x equals 0. And the whole reason why we factor something when it equals 0 is because if two factors multiplied together give you 0, one or both of those things must be 0. It goes back to that concept. If a times b equals 0, either a equals 0 or b equals 0. So that's the same thing here. Either x is equal to 0 or x squared minus 4 equals 0 or both. So here's one intercept right there. And then x squared minus 4, add 4 to both sides, square root both sides. And you're going to take, since we introduced the radical, we're going to take the positive root, which is 2, and we're going to take the negative root, which is negative 2. So I should have 3 intercepts here. I should have one at 0, 0. I should have one at 2, 0. And I should have one at negative 2, 0. Now, those are my x-intercepts. Now it's time to find the y-intercepts. So the y-intercept, remember, when you're looking at the graph, it's where it crosses the y-axis, and the x value must be 0. So I'm going to say y equals 0 cubed minus 4 times 0, and all of this wipes out to just 0. So 0, 0 is your y-intercept, which it kind of makes sense. We could have seen it right here. When x is 0, y is 0. All right, so those are my two intercepts. I do want to take you back over to Desmos so we can kind of get used to seeing, like, how do you get 3 x-intercepts there? So I want to be able to see what does that look like in Desmos. So let's come over here and let's type in that equation. So we've got, where did it go? X cubed minus 4x. And looky there, we got 3 intercepts on the x-axis, and our y-axis has 1 intercept at 0, 0, negative 2, 0, and 2, 0, just like we calculated out. Don't just type it into Desmos, because remember, CVCC will not allow you to use a graphing calculator on this. I want you to be able to come up with this stuff on your own. But as we use Desmos on any of these things, we can use Desmos to check our stuff, and that will allow us to become more and more familiar with these parent functions. And when you see an equation, like what's going on with the graph just by looking at it. All right, let's look at another one. Let's try out this one right here. Try y equals the square root of 2x plus 4. So pause the video, give that one a try. Find your x and your y-intercept. So when x equals 0, we get our y-intercept. When 0 is going in for y, we get our x-intercept. So 2x plus 4, the whole thing is being rooted here. I'm going to multiply, not multiply, but square both sides. So if I square both sides, I get 0 equals 2x plus 4. Subtract 4 from both sides. And so x equals negative 2. So when y is 0, x is negative 2. That is my x-intercept. And then for the other one, we're going to put 0 in for x. So y equals the square root of 2 times 0 plus 4. 2 times 0 is 0, and 0 plus 4 is 4. Now, in this case, we did not introduce the radical. It was already there. They wanted the positive root there. So this is just going to be positive 2. So when x is 0, y equals 2, that is my y-intercept. So already when I see this, I'm starting to understand, even though you may look at this originally and be like, I have no clue of what that graph looks like. Well, we now know 2 things about it. We know where it crosses the x-axis. We know where it crosses the y-axis. And as we learn these graphs, that's going to help us graph these weird things that we don't feel like we can graph, but you really can. Let's take a look at it on Desmos over here. And just type in the graph, see what it looks like, see if it matches up with our intercepts that we came up with. So if you start typing in SQRT, it comes up with the square root symbol. And in that, we want to put 2x plus 4. Actually, let's just look at x. As we talk about transformations, we're going to look at this as our parent function, the square root of x, and what does the 2 do in front of it? The 2 changes its shape a little bit. And then what does the plus 4 do? Plus 4 shifts it to the left 4. So right here, it crosses the x-axis at -2, 0. It crosses the y-axis there at 0, 2. That's exactly what we came up with. So that's always good that that checks out. Okay, that's all I got for you today. So I want you to take that practice, go through, find your x and y intercepts, become very familiar. Don't just try to figure out the quick, easiest way to find the x and y intercepts. Don't just graph it. Get it straight that you know that when the x value is 0, you're crossing the y-axis. When the y value is 0, you're crossing the x-axis. This helps with every graph we do this year. Every graph, it works the exact same way. You want to find the x and y intercept, put 0 in for one of them, and it will tell you the x and y intercept. Okay? Let me know if you have any questions. Let me know if you need extra practice. Thank you for watching, and keep working hard. Okay?